All right, so we're going to look at 207 graph vocabulary and guided practice. Some of these terms we've been using right along, so just reinforcing some of these terms. So together we're going to analyze the graphs on function 1 and 2, and then you are going to analyze the back page 3 and 4. So find the key features on the function graphed at the right. So here's my function. So the term increasing or decreasing, is this graph increasing or decreasing between x equals -2 and x equals 0? Here's -2, here's 0. This graph is decreasing because when I read it from left to right, it's going down. So it is decreasing when x goes from -2 to 0. What about when x goes from 2 to 3? So that's referring to this section of the graph, and that graph appears to be going up as I read the graph from left to right. So it'd be increasing when x is between 2 and 3. Again, this region of the graph is going up. What are the coordinates of the x-intercepts? So this x-intercept looks to be at -1, 0, and this x-intercept is at 3, 0. What is the coordinate of the y-intercept? So here are my coordinates. I would be at 0, -3. So being careful to use your x, y correctly. What about evaluate this function when x equals 1? So you're going to find on your graph x equaling 1, and you're going to see what the corresponding y value is. So when x is 1, y is -4. What is the maximum y value that this function will ever attain? So you can see that this graph continues to go up forever. So the highest y value attained would actually be positive infinity. This is the infinity symbol. I just am not great at drawing the sideways 8, so I just do 2 circles, but positive infinity. What is the lowest y value that this function attains? The lowest y value is down here at the vertex. It looks like y is -4. And what is the domain of this function? So it goes forever side to side because those arms keep pushing outward. So all real numbers. And the range, it starts at -4 and then goes up forever. So I would write the range as y is greater than or equal to -4. What is the axis of symmetry? So could I cut this graph in half? So the answer is actually yes. I can cut it in half right through the vertex at x equals 1. So the axis of symmetry is the vertical line, x equals 1. I could fold the graph in half over that line. All right, the next part, finding the key features of the function graphed at the right over here. So this time, what is the maximum, meaning the highest y value attained by this function? Looks like it's pointing towards positive infinity. So no matter what's happening over here, this graph's going to keep going up, 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 up. So positive infinity. What is the lowest y value attained? So this can go down, 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 down to negative infinity. So here's a new term. It's called local maximum and local minimum. Maxima and minima are the plurals. So any peaks in the graph, but we already know that the highest point is up here. So I do actually have 2 peaks on the graph. So a local maximum occurs at -4, 2, and also at 1, 0. So those are the coordinates of the local maxima. What about the local minima? So I do have 2 valleys in my graph. They're called local because this part goes down forever. So there is something below them, but they are a turning point on the graph, so they're called a local min. So this is at -1, -2, and this one is at 3, -1. So I hope that helps explain some of those new vocabulary words. So kind of a short day today maybe, but you're going to take your time, really do well on finishing 3 and 4 on the back using the new vocabulary, and you're going to post a picture of this back page of 207 using the assignment in Google Classroom. Thank you.